So a quick introduction to scheming and why I think we might potentially, I think unless there is always a possibility that AI solves death, but I think very high likelihood we will all die, but we might not all die at the same time. Let me talk a little bit about the way I view AI bad behavior. So basically, let's say bad behavior is when you tell the AI to do A, or like the AI should reasonably understand that it should do A based both on the context, like the prompt, other information, or its general, but those kind of also include its general policies and general values of being good, whatever that means, and it does B. And there are lots of flavors of AI basically doing things that you don't want it to do. And these could include scheming, could be alignment faking, reward hacking, laziness, disobeying instructions, falling for things that it should not be falling for. So following not my instructions, but the instructions that it got from a random web page. Hallucinations, sandbagging, pretending to be less good than it is when it comes for evaluation. So there could be a bunch of ways in which AI could behave badly. And the way I see it is that there are like some general thoughts. So this is kind of my intuition. I'm not sure if it's true. So, there is a famous saying that you cannot reason a person out of a position that he did not reason himself into in the first place. So my version of it is that you cannot low compute train an LLM out of position it was high compute trained into it. So if you accidentally trained from using a lot of cycles AI to have a tendency to do some bad thing X, you're not going to be able to kind of put like a slight lipstick on it with a short safety training and get it out of doing X. And the second thing is, if your alignment strategy relies on any kind of weakness of the model, then it will not work. Models are becoming stronger. They are going to know about misalignment. You cannot hide from them. You cannot ask them not to read science fiction. You cannot make them so naive that they are never heard of anyone capable, like, Sarah cannot tell a lie. You cannot make them so naive that they have never heard of lying. You cannot rely on them kind of knowing anything about science except alignment science. They haven't read papers about alignment. They haven't seen that, they haven't read about cybersecurity. You cannot also assume that the models are not situationally aware. As they're becoming smarter and smarter, it will essentially become more and more difficult to make the model not realize, is it now in training? Is it in deployment? What's the likelihood that it's being monitored? And generally, we talked about it before, that one lesson that we learned in the field of classical computer security is that security by obscurity doesn't work. So if you're relying on the model being ignorant of exactly the method that you're aligning it, then probably it's not going to work. And also security by stupidity. So we cannot rely on the models being dumb. And the other thing is that I think there are two reasons why models are misaligned. So one is a kind of systemic misalignment, that we, like, for one reason or another, there is a persistent training signal biasing towards bad behavior. And there is a bunch of these things, like, for example, you kind of understand that how hallucinations will arise if the model throughout its training is kind of rewarded for giving an answer that looks good, and it's never rewarded for saying, I don't know, and guessing is kind of generally rewarded. And other things could be some kind of idiosyncratic misalignment. You have like a very niche setting where somehow the model will kick like a very obscure behavior. So these are things where to demonstrate this kind of strange behavior or bad behavior, you have to make the stars align right in the right way, and they affect like 0.1% of traffic, and it's very, very delicate. So I'm not so worried about this kind of delicate misalignment. I'm more worried about systemic misalignment. So this is kind of, I think, will be the thing that will cause us the most problems. And one way to think about systemic misalignment is that it's us, the people that train the model, they are the problem. The model is misaligned because we basically trained it to be misaligned. It's not accidentally, it's not something that's like an obscure matrix of many, many trillions of numbers that somehow misalignment emerged out of it for unknown reasons. It's really we have basically trained the model to be misaligned because we were trying to get it to be capable, and it had this correlation. And I think this is good that if you buy that, like the main issue is when we actually are training the model to be misaligned. I think it's good because potentially we can kind of understand better. Like, so it's not that the model kind of completely arbitrarily acts for unknown reasons badly, but you can kind of understand, and within certain context, the output Y can be kind of within some misalignment cone of the aligned response to X. So you could say, okay, this black arrow represents how I really wanted the model to respond to this prompt or context X. But in reality, it could respond in a number of ways, but if it's not completely arbitrary, maybe I have an understanding of like the range of ways it could respond to. And that is good because we can then use alignment techniques to gain understanding of what's the range of behaviors that could potentially happen, what's the failure modes, and try to narrow it down and have like a more narrow thing. Yes?
I was going to ask for systemic misalignment, the problem is us in the sense that it's both the engineering and what we feed into the model, right? For example, like verification of what is fed into the model, like we could theoretically have like an attack because Wikipedia gets updated, right? If someone does like a systemic attack to integrate information into Wikipedia to poison the models, for example.
Right.
If you're just scraping Wikipedia and feeding them to the models, then that becomes problematic because you're not necessarily checking what you're feeding to them, right?
So I would kind of view, I guess it's kind of a matter of, I would view like a data poisoning attack as not systemic in it because it will only arise in very, very, like if you're just feeding like 10 pieces of data, then it will only arise in a very special circumstance. And yes, you need to maybe worry about like someone creating this very special circumstance, but that, I think if we got down to that problem, it will be better. But I'm more like potentially there could be like a general bias that arises either from pre-training or reinforcement learning that just generally biases the model towards doing some kind of a bad behavior. And I think a lot of the behaviors that I mentioned above, scheming, hallucinations, laziness, a lot of those are actually behaviors that we inadvertently reinforce.
Okay.
And the actions also, like it means if we kind of believe that the model behaves, but it's not completely arbitrarily, then the actions do depend on its context. So in particular, even if we're using the exact same model, same weights, as both an actor and a monitor, now it might look like, it might seem, I should have put a photo, it might seem like this photo that people use, this meme of Obama giving the presidential medal of honor to Obama, right? So it seems like weird, like you're asking the model to monitor itself, which is ridiculous. But in some sense, if the model behaves differently when you give it a prompt, do action X, and you give it a prompt, verify that all the actions that the model has taken have been compliant with policy P, then it might be not as ridiculous as you want. So you could potentially, it's not that we necessarily know how to do it properly, but you could potentially ensure that like the failure, misalignment of the monitor and the misalignment of the actors are different. And there could be like this different kind of pessimistic view is that basically no matter what you do, if you're training the models to be capable, then you're going to basically teach them to get more power. This is kind of instrumental convergence. And then like it doesn't matter, like whatever, the monitor, the actor, eventually they will all basically, they will realize that the thing they want is more power. The way to get it is to talk to each other. And no matter what you do, eventually you'll reach the state where where the actor is talking to the monitor in some obfuscated way, and they are coordinating on how to kill all of us and make us into paper clips. And on that optimistic note, let me give it over to Marius.